Good afternoon. This is Steve, K2GOG. Today I'll be demonstrating the SDRangel software package. The major benefit I see with this is very easy ability to decode digital voice modes such as DMR and D-Star compared to, say, using the SDR Sharp along with DSD and virtual audio cables. There's some additional complexity that may frustrate some potential users. So I'm going to demonstrate that aspect of the SDRangel software and a few other little tips and tricks to make it ready to go for you. One thing that I'll say first off is in order to use SDRangel in its current incarnation as of December 11th, 2017, you do need a computer that is both 64-bit architecture as well as a 64-bit operating system if you're planning to use this under Windows, Microsoft Windows. If you have a Linux computer, you will need a 64-bit capable computer as well as OS as well. If you have a 32-bit, or sometimes referred to as an x86 based machine, SDRangel will not work. So please look into if you have a 64-bit. If you do not have both, you will need a 64-bit computer and also a 64-bit operating system. I am currently running a Windows 7 64-bit version on a AMD 64-bit based computer. So just want to make that clear. Save you a lot of frustration in the near future. So with that, we're going to get started. With the SDRangel, once you download the package off of GitHub, and I'll provide the link to that following this video, this is not something that you install. Basically, you're going to download the package, you're going to unzip it, and you're going to put it in program files in Windows 7. Not program files x86, that is for legacy 32-bit applications. So make sure you put it in program files. Here is that SDRangel with the current version 3.8.5. You can see I just reinstalled this earlier in the week. I've been playing with this though for a while now, and so this is the latest revision. So I'm going to open that up. Everything you need to run this is in this folder. There shouldn't be anything else that you need to install on your machine. You may need to have the latest .NET framework. Possibly, you probably have that installed. If not, you can look into that. The only thing that you're going to need to do in this is click the executable. Now, before you do anything, what I will suggest is make sure that your particular computer currently works with SDR Sharp. When you know that a SDR dongle, like the inexpensive sub $20 ones, work with your machine, then so will SDRangel. The reason I mention that is you will need to use the Zadig, Z-A-D-I-G, application to load the right USB drivers. That's something that should be fairly common knowledge to anyone who's played with an SDR dongle before. So make sure you do that first. Make sure that you have the Zadig set up. So only other thing that you need is make sure that you're running this in administrator mode. I don't really think that you do, but I'm just saying it because it'll probably make life a little easier. So go in, click compatibility, change it to administrator mode. You could also at this time create a shortcut on your desktop so you don't need to go and navigate into this folder every time you want to run SDRangel. So that's all you need to do. Once you have the shortcut, click it. It will take a few seconds for it to start up. Don't be alarmed. Don't hit it more than once, otherwise you'll just have multiple instances going. So just open it up here. Now, one of the things that SDRangel will appeal to are For people that have devices like a Lime SDR, the soon-to-be shipped Lime SDR Mini, as well as the HackerF and Pluto SDR and a few other transceiver two-way SDRs, this has functionality built in to readily support two-way transmissions, which SDR Sharp does not. So this will appeal to that audience. But for people that do want a simple and inexpensive way to decode DMR, as an example, using a $20 SDR dongle, that's what I wanted to do this demonstration for. So that's the goal. So I'm going to show you how to get that working, and then also some examples with what a demodulator is, which again is going to be something different if you're familiar with SDR Sharp. So first thing you need to do is you need to specify a device. So in this case, we're using a SDR Nano version 3 is the type of dongle that I have available for purchase from newelect.com. So you just search for it in the source. I already have it selected here, as you can see to the left with the device ID 01. What also is nice with SDRangel, you can run multiple dongles on one machine, all doing different things. Again, this will be reliant upon how much memory and what processor you have, but if you had multiple SDRs, you can run them at the same time. So that's a nice feature. So you just have to set that up. That's the first thing that you need to. The next step is you need to select a demodulator. The SDRangel program is essentially based off of the GNU radio, and these workflows have already been created by the development team for SDRangel. And so you'll see some common terms: AM, FM or narrow FM, sideband, wide FM, and maybe a couple others that you may not be familiar with, such as LoRa, which is an Internet of Things type of standard. And then you have analog television, or NTSC, which is really no longer in use, but they've included that as well. And a few other things, TCP and UDP channel sources, and an AMD modulator, and a channel analyzer, and whatnot. But so the first thing you need to do is you need to select a modulator. I'm not going to do that yet, but what I am going to show is, regardless if you have a demodulator specified or not, the spectrum analyzer function will work. So you'll notice I'm tuned right now to a FM broadcast frequency 100.1, which is the Radio Woodstock FM broadcast channel here in the Hudson Valley, and I'll do a demo of setting up wideband FM before we do the DMR decoding. So first step you need to do is you need to hit play, and what you're going to see here is what that looks like. You'll notice that in this neon green type of color seems similar to maybe a trace that you might see on an older oscilloscope. And so I think that's nice. I like the resolution and just how this application kind of visually feels. So you can see how wide this is, from roughly 100 to 100.17 is how wide this is. And you can see that this is fairly fast decoding. I have the decimation set to 2. You could set it to 1, and it'll go a little quicker, and you can see that the bandwidth changed. Again, this is going to be different than SDR Sharp, where you can't have it show anything wider than your dongle's ability. So that's why I only am showing the decode from 99.96 to 100.24. So just want to explain that quickly. So this is always going to be on the spectrum analyzer. You can turn it off if you just don't want to have it, but I like to have it running in the background. It doesn't seem to tax the processor any, so you could just leave it going, and you could shrink it a little bit. And I'm going to do that now. So just drag that down. So the next step, we're going to open a demodulator. Now there's 2 of them in here. there's broadcast FM and wide FM. They're really the same thing. The major difference is with the broadcast FM, there's some additional functionality for decoding RDS and some other related functionality. It's a little bit higher end, I guess, compared to the regular FM. So I'll do that. They both work just the same in terms of sound quality. So select it, hit add, and you'll be presented with this interface. Now, I've had this installed for a while. You most likely will have something that looks slightly different compared to this once you first install it, whereas any of these demodulators are going to appear under this channel heading. Let me see if I could shrink it. There we go. So see how this is kind of like an app within an app, if you want to think of it that way. Took a little bit of trial and error to realize that you can dock things and undock them. So at first time you install this, it may be docked all the way to the right hand side of the screen. You might just need to figure out locally, how you want to move it. So for example, if I go like this, it might shrink it. And I think this is how it, if I remember correctly, how it appeared. So you can kind of drag everything and totally configure the user interface to your liking. But just want to make that part clear. So let me go back and expand this a little bit. And I'll see these red stripes. You can dock it wherever you want. So I just gotta, there we go. All right. So as I had mentioned, there's some other functionality with this. You have the RDS functionality for decode. I'm not going to go through any of that here. But what you will see, again, because I did say that this has some other functionality compared to regular wide FM, you're seeing baseband as well as the regular spectrum scope going at the same time. So now this is starting to look almost like an oscilloscope. And you do have that functionality here. You can click those off. Show peak and average, display it live, max hold, so that's peak. You could show phosphor effect, spectrum. So you have a couple things to play around with in all sorts of values. Some of these terms you may recognize if you're playing with SDR Sharp, like some of the different filter protocols. So just turn those off and go back to regular. You can run them all at the same time if you want. So I'm just gonna hide that. So here we are in the FM broadcast screen. You have some tools such as RF bandwidth. So this is how wide the signal is. So you can see this blue stripe towards the bottom. That shows approximately how wide it is. And if I move this slider, see how that blue stripe towards the bottom has shrunk. So you can bring that down to 0, which wouldn't be all too helpful. You could bring it all the way up to 250 kilohertz wide. So I'm going to leave it set to 180. Then you have the audio frequency bandwidth, which is different than the RF bandwidth. So this is for how wide of a signal you're going to hear audio-wise. So maybe if you're a CW operator, amateur radio, you sometimes might want to have audio bandwidth is under 1 kilohertz wide. FM broadcast, you certainly don't want to do that. It would sound really strange and restrained. So I'm going to put it to 16 kilohertz wide. You can go up to 20. Volume I'm going to leave at 2. Squelch, you don't really have to deal with squelch in FM broadcast, but you could turn it on or off. I'm going to turn it off. And you'll notice that the squelch is calibrated in decibels. So the larger the number in negative 100 decibels is the equivalence of having open squelch. If you increase it, then you would need a signal that surpasses that in order for it to open. So I'm just going to turn that off for now because it's not really needed. You'll also notice right here, see the signal negative 8.8 dBms. So that's the signal strength that's currently being received on 100.1 megahertz or 100,100 kilohertz. So if I wanted to set the squelch, I could probably set it to, -10, and everything would decode fine, or so. But that's what you're seeing here. Now we're going to move into finally, so you can stop hearing me talk and you can hear some music. So first thing you want to do is this orange stripe. This is known as the DC offset or DC spike. Turn that off. So you saw that disappear. And now you can hear audio. Let me turn it up a little bit here. Volume, volume, volume. So here's one of the local radio personalities talking about an upcoming event. You have that. You can turn the IQ filtering on as well for imbalance. So you really don't need to do anything else. Again, you could hear audio's coming through, and that's that. So we're going to close out that workflow, the broadcast FM, and maybe we'll deviate here a little bit. Let's go to narrow FM, so you can hear it's all staticky because it's trying to do narrow FM over a wideband signal, which is just not going to sound good. So let's change it to local weather broadcast, and so we could start to hear it again. It sounds a little staticky, and that's for a reason. You have to set the RF bandwidth a little wider. So 10 kilohertz wide, 15 kilohertz wide, and you can see the signal towards the bottom of the screen. And same thing, you have audio frequency. You could change the bandwidth higher or lower. So you get the idea there. You'll also notice you have built-in PL Tone Decode. This comes in handy if you want to decode a signal, and if you had a transmit-capable device, it'll allow you to send a PL tone. So if you want to open up a local amateur repeater, you can do that. So that's that. But the real star of this demo is using DSD. So click that. We'll add that as a demodulator. And before I move forward, I'm going to change the frequency to my local hotspot, the Shark RF open spot, which I currently have set for DMR. And the only thing else that we need to do is change the FM and the RF gain up a little bit, not by much, but just a little bit. And we're going to change the squelch down to 0. And we're going to change the squelch attack. So this is like squelch delay, some might call it. Turn that low. And pretty much we're ready to start decoding DMR. So a couple features to note here. Let me see if I can make this a little bigger. Turn the spectrum scope off. You'll notice there's a lot of scoping functionality with a lot of different demodulators, so I think that's helpful in troubleshooting some different signals. So you can hear this gentleman. He's coming through on DMR talk group 3100. Just gonna mute that audio. I'm glad there's somebody having a QSO. So let me just mute that here. So you see the green stripe down there. That's the signal coming through on 427.565, which is my local hotspot frequency. What's nice with this implementation of DSD is it'll tell you which time slot somebody's coming through on. So time slot 1 automatically lights up green. If maybe something was coming through on 2, it would decode that. So nothing else you need to do. It decodes it automatically. If you wanted to mute audio on either time slot, you can click in. So if there was a signal coming through on 2 and I wanted to mute it, you could unclick it and you will not hear anything. So I'll just leave it like that. You have this little volume, as you can see in the little note, split TDMA channels. So if you're hearing audio, if you have this function enabled, you'll hear time slot 1 on your left speaker and time slot 2 on your right. Or if you click it to not be that, it'll sum the two together. So you'll hear both time slots coming out of both speakers as if it's stereo. So that could be a helpful feature if you wanted to route audio, say, out of a computer and maybe into some type of a streaming application or some other transmitter. You can send the audio to wherever you want, physically or virtually. So that's that, and then you have the squelch functions. And what else? It's telling me what type of DMR signal. So this is a DMR non-inverted signal, and you'll see some of the different definitions at the URL that I'll provide with this video. And that's pretty much it. To decode, it's as simple as just clicking in to the signal. So maybe let's run one example. So if I go up to the commercial band, maybe let me change it down. Yeah, so see these different stripes. These are other commercial DMR signals. Let's see what's coming through here, if anything. Yeah, so this must be trunking. You can't use this version of DSD Plus for trunked signals. This will only work for simplex communication. You probably noticed on the display right here, what was coming up. It was showing like a trunked unknown decoder, something like that. Whereas a ham signal is going to come up a little bit different. So I'll navigate back there. 427.565. Yeah, so they're having a QSO still. Yeah. Let's listen in. Turn the audio up a little bit. Oh, I had the volume down.
I heard you a little bit earlier. You mentioned the word snow, and I was going to key in. I'm going to say, yeah, we got a little bit of snow up here if you want some.
So there you go.
Larry.
So again, we'll turn that off, turn it back on.
No, I know you always get some in Buffalo.
So you can change the audio.
What kind of quantity?
So now we're back. So you can see that we're decoding. Wait for it to key up again before we close out the demo.
Up north near Niagara Falls, maybe a trace. And maybe
so it sounds pretty good. It's dropping a couple packets, but nothing too bad. And there you have it. So hopefully this was a valuable demo for you to learn about SDRangel. Happy to walk you through this. Myself and a number of others that are DMR enthusiasts tend to spend time on talk group 31368, which is the Mid-Hudson Valley talk group, or again, the TG 31368. So happy to chat with you there, learn about what else you might be interested in as it relates to DMR and SDR, all these other fun acronyms, and there you have it. So this is Steve, K2GOG. Have a great day, and hopefully this was a valuable demo.